I'm sharing now, it is on the page 33 in the training handout or guide. And again, it is called Parametric Components. The first step says that for this exercise, download the entire folder and work with the files from the local 24/7 folder where the files are downloaded to. I will quickly repeat how this works. If you're working with the web browser version of 24/7, then you will of course give it a destination where it is saved, and you should be able to locate this folder again. If you're using the Bricsys 24/7 panel in BricsCAD, you will access it as before with the panel here and logging in with your credentials. Also, to repeat, if you do not have access to this panel, you can right-click somewhere on the ribbon, hover over the panels sub-option, and here you will be able to find the Bricsys 24/7 panel or any other panel that you wish to access. I will then make my way through the folder structure, sales, training tools, BricsCAD mechanical training, V21. And I will then go to folder number 7, parametric components. If I right-click on this, I can download the entire folder. As it is downloading, it will download all the content of the folder. If you know where to locate these files that have been downloaded in your folder system, you can locate these to open the relevant file for the exercise. If you do not know where it is downloaded to, you can type in the command settings. Then the settings window will appear. From here, you can go to the section called Program Options, scroll down to the option Bricsys 24/7, and find the section called Cloud Download Path. Here you can find the folder path for the files that have been downloaded through the Bricsys 24/7 panel. You can even select this path and you can copy it. Then you can, at least on Windows, which I am using, I can then go to the top bar here and I can paste the path and search for it. And then it will take me to the folder location for me. And here I can find the folders I have downloaded. So continuing with the steps, I will then go ahead onto the step number, or still in step number 1, it is telling me to open support_2.dwg. So I will start with that. And here it is. I will just resize my panels to make a bit more room for my model space, and then move on to step number 2. On the bottom of this screen, you can see the command line as usual, but on top of the command line, you can see there is a tab called Model, which is what we are currently using. This is the model window you can see here with the Look From tool and the model and everything in this white window. If I press on the tab next to it called Layout 1, I will be taken to the paper space of this model. Here you can see a sheet of paper where there has already been placed some drawing views for us. There are some base views, or a base view with a projection, and there are 2 section views as well. These drawing views are associative, meaning that they will automatically update according to or to reflect changes that I make to the model that we have in the model tab. And throughout the exercise, you will be able to see the drawing views update as we go along with the steps. So I will go back to the model tab for now and move on to step 3. It is asking me to open the file whole edge _2. I will find it in the same location as the support _2 file, except in the folder features. And here I can find the whole edge _2. You can see here that this is it is called whole with edge. The reason for this is the purpose of this file is to create a hole in the part that we will insert it onto. It will also add an edge around the hole. The way it does that is that it consists of these 2 transparent solids, as you can see. If I open my layers panel, you can see there is a layer called BC_subtract, which is given by the red color. The naming, the specific naming of this layer allows us to use this solid to subtract solid from any part that it is inserted onto. So the red solid here that you can see will then subtract material from the support _2 file, as you will see later. Meanwhile, the BC_unite layer will allow the green solid to then add material to the file, as you will see later on. In the mechanical browser on the left, you can see that it is also fully parametric. It has several parameters as well as constraints with mathematical equations and such, somewhat similar to what we did yesterday. I can then try to change the diameter, for example, from 1/2 of an inch to 1/4 of an inch. You can see the hole adapts to this change in diameter. I can also try changing the depth, for example, from 1 to 1.2. And you can see it change as well. So now that I have opened it and I have inspected it, I know how it will work and how it will affect my model. So I think I can go ahead and close this one and then move on to try and insert it onto my model. So I will go back to the support file. I will then use the insert component option or the bm insert command. And then I can then locate the correct location for the parts through my folder structure. Here I can see the whole edge _2, which I will open. And now I can apply it to my model. Similarly to the first exercise yesterday, I want to place it according to the fillet curvature here. I wanted to share the same center. To do this, again, I have to ensure I have the right eSnap settings enabled. I need the center snapping option enabled. And I don't want it to attach to any of the other faces or on the fillet. So I will also hover over this top face and shift lock it by clicking or pressing shift once. I can either check my eSnap settings down on the status bar in the bottom right, or I can hold shift and right click on my mouse to then see this option is enabled If not, I can click snap to center and I can then hover over the curvature and then find the snapping point for center appear. And I can then simply click it to place it on here. Now I placed one hole. I want to place more of them. I actually want to place 3 holes in total. So I will open the insert option again, or command. But instead of having to open this command every single time, I can go down to the command bar and I will activate the multiple option in the command line dialog, allowing me to place several of these. And I will repeat the same thing on the other side here. I will shift lock the surface, ensure I have the right snapping options, and place it. Now I want to place it over on this face as well. It seems like they are on the same level, but I am not 100% sure, so I'm not going to risk it. I will then press shift again so I can unlock from this face. Then I will hover over this other face and I will shift lock this one instead, just to be sure that I am placing it on the correct surface. I will then make sure I have the right settings, snapping settings available, and find the center point of that curvature here. Then I placed all the holes I wanted to place and I will exit out of the command. Now you can still see the unite layer and the subtract layer is visible here. I would like to remove these, which is in the step 7. I can then go to the layers panel and I can locate the layers and turn off the visibility from here. I can also go to the top of my ribbon in the top left of the screen. I will have this layer control section where I can select this drop-down menu. And I can also locate the layers and turn off the visibility for them by clicking these light bulbs. And as you can see, they are hidden from the model, but they are still affecting the model in the way I want. So you can see it cut away the material with the red geometry that we saw earlier, and the green geometry added this lip or edge around the hole. If I try to select it by hovering over it and holding down Control, you can see it selects or highlights the entire model, not just the edge. So it doesn't just add material to the component, it also unites it with it, so it is the same solid. Now I have changed the model a little bit, so I can go ahead and check out my drawing views and see if they have also changed. And in fact, they have. You can see here the lip and everything with the hidden lines of the whole structure or whole geometry. You can see them in both the base view and the projected view. Also in the section views, like here, and this will also be true for any detail views you might have on your drawing. Now, if you take a look at the mechanical browser, you can see that the 3 holes appear in the mechanical browser as external references. And in the substructure of each of these, you will see that they still have parameters attached. So I am still able to modify the sizing and such of these holes, even after I have inserted them. You can also see that previously the value was given in inches. However, I placed them into this file, which is made in a millimeter template, and the value adapts to that. I can then try to, for example, change the value here, the diameter from 12.7 millimeters to 7 millimeters. And you can see it changes accordingly. Now I only changed one, but I can also change or select all of the holes at once, and I should be able to change all of them. So just selecting them multiple ones by holding down Control and then changing the value in the bottom of the mechanical browser, you can see I changed all of the values at once to a smaller hole size. And even when changing these parameters, the layouts will also adapt. And you can see the geometry has been updated. Oh, and the same is also true for the depth or any of the other values as well, of course. Next up, in step 10, I'm going to open yet another file that I will locate in my folder system. I will not insert it just yet. I will just open it. I want to also see exactly how this works before I choose to insert it. This part is also, or this is called a rib. With this rib, we want to add some additional support to this cylindrical geometry here on top of our model. You can see that in the layers panel, it only uses a BC Unite layer. So this will also unite with and add material to my part, similarly to the lip or the edge of the hole. You can see that also this in the mechanical browser has different values like the angle and height. Now let's say I want to use this not only on my component I have opened in the other tab now, I also want to use it on other projects perhaps. Then it can be useful to maybe create it as a library component. If I go to the library panel, I can see here I have access to things like holes, sheet metal features, and just general standard parts. In the bottom of the window, I can see that I have a plus sign. I can then click this plus sign and I can then get this window here where I can add a component or a part into the library panel of BricsCAD. I can select what entities I want to become part of this block in the library. However, in this file, there is only this rib, so I might as well just select entire drawing. I can then give it a name, for example, rib, since it is already conveniently named as such. I can then choose here a drop-down menu to select the other folders here that I can place it in. I already have a folder here from demo from doing this earlier today, but if you want to create a new folder, like it says in the handout, you can just type in a value or a name for a folder here, and it will create the folder for you. Here you can also see where it will be saved. You can also see more options for insertion units, for example, but we will keep it to millimeters. Then you can click Create. Since I already have it, I will replace it. And you can see in the command line dialog that the command generated thumbnails for me, and it should have been made now. So here in the library panel, you should see the demo folder appear that you named, and you should see the rib part that you created. So let us now go back to the other file and we can try to insert it. If I then select the rib, It will be appearing on my cursor in the model space. I want to snap it onto this surface here, the surface that revolves around this geometrical or the cylindrical geometry. And I want it to snap onto a quadrant snapping point on the bottom here. I'm having some difficulties finding it, so I can then check my snap settings, and I can hold Shift and click my right mouse button, where I can find the snap to quadrant option. And from there, I can then try to snap onto the quadrant. This is on the cylindrical face, but on the bottom edge of it. If I click there, you will see that it appears, and it has now been added to the geometry of the rest of my part. Now, it had a purple hue earlier on. This was the color of the Unite layer. This automatically disappeared, but that is only because we already had the Unite layer visibility switched off. If we switch it on, you can see that it changes its color slightly. Now, following this, I want to have more than just one support here. I want them to move around my circular geometry here. So I can then select my part. I can select this line as this is a part of the block reference. I can also go to the mechanical browser, locate the rib, right-click it, and then I can choose the select sub option. If I go to the solid tab, I can then find the array option under the edit section. With the drop-down menu, I can find polar array. The polar array will then create a circular array as opposed to the path or rectangular array. I can also type in the array polar command, but I will access it from here. I can now choose a center point for the array. I can then immediately select the center point here, and it should revolve around it. It will revolve around this since I placed it on the circular face already with the quadrant snapping. If you have not defined any kind of circular location yet, you can then again use the axis of rotation sub option, and you can draw a line that goes through the middle from the top to the bottom here, for example, and it will define a center line it will revolve around. But I will just select the center here. Now it will only show me these lines first to show where they will show up in the array. This is because it uses the Unite layer and the visibility is switched off. Therefore, the solid itself does not appear until I accept the selection or exit the command. Once I do, the Unite layer will do its trick and will create material to attach to the rest of the solid. Now, now that I have created this, you can see in the mechanical browser, a polar instance appeared. This polar instance is the array we just created. And if I select it, you can see I have some options in the bottom of the mechanical browser, such as changing the radius, for example, of the array. I can change the angle between the items and such. I can choose to only have the array in a revolution of 180 degrees, for example, only half around here. But of course, here I want it to go all around. So it is at 360. If I want to add more items, I can change the value of 6 to 8, as it says in the handout. And you can see in the model, it automatically updates to add more items. And it decides the distance between the different instances as well for me. Now I'm just going to the drawing view to check that everything is updated, and it is. I can see all the different ribs show up here in the base view, the projected view, and the section views. If I go back to the model tab, you can also see that under the Polar instance in the mechanical browser, you can see there is a folder called source. This is where you can see what has been arrayed basically. And you can see that it is the rib and the underlying parameters are still available. So I can try to change the angle of this still, and I can try to change it from 45 to 55 degrees. As you can see, it still updates all of them. And you can change the height from 30 millimeters to 43, and the height will update as well. Now, if I go back to the layout tab, you can see that it also updates here in all the different views. So this concludes the first exercise. Now you will have the chance to try this out for yourself, and we can move on to the breakout rooms.